Hello, welcome to Reality Part 2. A quick recap of what we said so far. Reality is points that hold an ordered list of numbers. The points' placement in relation to one another is continuous, so they form a structure. In actual reality, the points form a four-dimensional structure. So they are placed in four different ways, one in relation to the other. We will use a model that is a two-dimensional slice from the actual four-dimensional structure. In our description, reality does not change, so the numbers of each point are set. The ordered list of number of each individual point is permanent. We assume reality is governed, and we mentioned that it is important to notice that in our model there are two we. One is the regular self that has our experience, and one is an imaginary perspective that has an outside view of reality. To continue, I want to elaborate how we get the two-dimensional slice from our actual four-dimensional structure. So we are losing two dimensions in this process, and I want to see how we lose these two dimensions. However, because we cannot see four dimensions, we will use a three-dimensional model and lose from it two dimensions, and from that understand the process. So here we have a cube, which is a three-dimensional structure. The points in it are placed in three different ways, one in relation to the other. And we will use this as an example and build a model of it. So we need to lose two dimensions, and the way it happens is the following way. We slice in one direction, slice the slice in another direction, and we are left with a one-dimensional line. Notice that this line is part of the original cube that we started from. So the model is part of the cube, and the three-dimensional cube is made out of infinite amount of these one-dimensional models. To get a feel for that, let's go back in the opposite direction and build the three-dimensional cube from our one-dimensional line. The way to do that is to copy the line infinitely amount of times in one direction, which will give us a two-dimensional plane, and then get this whole two-dimensional plane and copy it in a different direction an infinite amount of times, which will give us back our three-dimensional cube. So if we take this analog to the two-dimensional model that we will work with in this video series, we need to copy this two-dimensional flat plane an infinite amount of times in one direction, which will give us three-dimensional space, and then take this whole three-dimensional space and copy it in a different direction an infinite amount of times, which will give us the four-dimensional actual reality. But we cannot imagine how to duplicate three-dimensional space in a different direction, and that's why we used this example in front of us. The important thing to notice is that the model reality is part of the actual reality. So it's not like we're just taking a two-dimensional flat plane and saying this is reality. This is a slice of the actual four-dimensional reality. And this is important because some features of reality depend on the number of dimensions. So our two-dimensional model will have features of a four-dimensional reality. These features would be different if reality was actually two-dimensional. So configurations that exist are a result of the play in four-dimensional reality. And this means the configurations depicted take into account two more dimensions affecting them. So they cannot really exist if reality was actually two-dimensional. And we'll clarify a little bit more about this shortly. To continue our recap, we said our model reality is a two-dimensional infinite flat surface. We said flat equals dealing only with special relativity for now. And we said that special relativity equals a reality without gravity. So we start with this model, imaginary model of a reality without gravity, see how it looks and behaves. And once we understand it, we can reintroduce gravity and see how the model has to change. As we said, every point in this two-dimensional model of reality holds an ordered list of numbers. And now I want to elaborate a little bit about these lists. We will divide them into two main categories of attributes. The first one is properties, and that is equal to saying that the point holds charge. And the second one is information about properties of other points, which equals to saying that that point holds a field. Now there is a link between the two categories. The charge creates a field. It is the source of the field. And a field affects a charge. And we'll explain what this means also shortly. Now, not all points have properties. So if we look at a point in reality, it has its ordered list of numbers, and we divide this list of numbers into two categories. Let's say the first three places are connected to properties, and all the rest of the places are connected to fields. So what we're saying over here is that every point in reality will have some values that are not zero in the field places of its ordered list of numbers, but most points will have zero values in its property places of its ordered list of numbers. So in our example, let's say the first three places are connected to properties. Most points will have the value 0 in these three places. However, we will have some points that have at least one place in their charge placements that is not 0. And if we look to all these points that have properties, we can identify they form continuous lines. In every line that we identify, so there are separate lines, and every line that we identify, the property numbers are the same. That is equal to saying that line is an elementary particle. Notice that we identify these features, these lines, from our imaginary outside perspective. So here we have our lines, and each line is constructed from points that have at least one non-zero value in its property part places of its ordered list of numbers. So if we look at this line, for example, then if we look at the point over here, it holds numbers in its, let's continue with our example, first three places of their ordered list of numbers. So let's say 3, 5, and 7. And then if we look at the point over here, it will also have the numbers 3, 5, 7 in the first three places in its ordered list of numbers. If we look to this line over here, again, it will have some numbers that are not 0 in the places of the property numbers in its ordered list of numbers. This could be the same numbers, 3, 5, 7 again, and in that case, this elementary particle will be the same type of elementary particle as this one, but it could be that the property values are different, let's say 3, 6, 2, and in that case, this elementary particle is a different type of elementary particle than this one. And if we look at the point that is not a part of the line, any point that's not part of the line, the first three places in our example that are connected to the property values of the ordered list of numbers will be 0. So any point over here, the first three places will be 0. Now these lines are called world lines. And they are also lines in the four-dimensional actual reality, not only in our two-dimensional model. And to connect these elementary particles a little bit to our own world, a thing that we identify in the actual world is a collection of elementary particles that have a bigger path. And by bigger, I mean that there is a way that we will specify later to define what this path is. So for example, if we look at these two elementary particles, we will specify a way that allows us to identify a bigger path for them, which is this yellow thick line. And this means this yellow thick line is a thing, which is comprised from these two elementary particles. An important side note, going back to what we mentioned earlier in the video, the world line configuration that is presented takes into account that we have two more dimensions. So the configuration depicted cannot exist without the presence of two more dimensions, which come into play with the world lines that are depicted and allow for their configuration to exist. But nonetheless, the depictions are not a mathematical solution to reality's rules. So this is not a specific solution to the rules that we are in the process of describing. It is representation of the concept. So this exact specific depiction may not be a viable solution, but it represents the concept of world lines and what they can do. Going back to the description of reality, if we look at the information related to a property of a certain point, so the field, we identify it is located on points that are tracks that go through this point. Again, we identify these tracks from our imaginary outside perspective, looking at reality from outside. So if we look at this point on this world line over here, it has property values, it has charge values, and these charge values are the source of a field. A field is numbers in other points that are correlated to the property numbers at this point. So what we're saying over here is not all points in reality are correlated to the property values of this point, only certain points in this reality, and these points are along tracks that go through this point. And these tracks are these two pink straight lines that go through this point over here, which means that if we look at the point on this pink track, information track we'll call them, then at this point the field values in the ordered list of numbers are correlated to the property values in this point in the ordered list of numbers of this point. And the same for a point over here on this information track. Its field value numbers are correlated to the property values at this point. And the general rule of the correlation is the further you are along this track from the source, which is the properties over here, the charges at this point over here. So the further you are along the track from the source, the field values are lower. Now it is very important to understand that the tracks that we identify exist in the structure of reality. And this means that we, with our outside perspective, can align ourselves with a certain direction of reality. And when we align ourselves with this direction, the tracks are all the straight lines that go through a point and create a specific angle with our perspective, which I'll remind you is represented by the gray grid lines. And in our model, we will choose an angle of 45 degrees. So if we look at any point in reality, so for example, this point over here, it has information tracks that go through it. And the information tracks that go through it are all the straight lines that create a 45-degree angle with our perspective of reality, which in this case we'll choose as the vertical lines. The vertical line that goes through this point, a vertical gray grid line that goes through this point, any line, straight line that creates a 45-degree angle with this vertical line is an existing information track through this point. And in this case, in our model, there are two such lines. But the totality of these tracks going through one specific point of reality are different depending on the number of dimensions reality has. So the more dimensions we have, the more options for such information tracks, such lines that create a 45-degree angle with our perspective, we have more options for these lines. And this means that in actual four-dimensional reality, there are more than the two straight lines that we see in our model. But again, because we cannot imagine four dimension, I will use a three-dimensional model of reality. And in that case, all these lines together form two opposite cones that originate from the specific point that we are looking at. And it looks something like this. So here we have our three-dimensional model of reality, the cube. And we're looking at this red point, one of the points in this reality. We have a vertical line going through this point. And all the lines that create a 45 degrees with this vertical line, our perspective of reality, are information tracks that exist and go through this point. So as you can see, there are a lot more options. So there are a lot more lines than the two that we had in our model, our two-dimensional model. And all these lines together create two opposite cones. And when we add one more dimension to the four-dimensional actual reality, there are even more options for these lines, these information tracks that create a 45-degree angle with a vertical axis that goes through this point. But we cannot imagine the structure that all these information tracks create together. Okay, so going back to our two-dimensional model of reality, each point we can find two information tracks that exist and go through it. So at this point, these two lines, at this point, these two lines. At any point that we look at, we have two information tracks that go through that point. Now, this means that information tracks cover the whole of reality. And this means that I will only depict some of them because they cover the whole of this two-dimensional flat surface. Now, if we put back our world lines, this is the depiction that we get. And we will look at this world line over here. And we will give it a name. So this will be Alice. Then if we look at this point on Alice, this point is part of a world line. It means that it has charge values in the charge places of its ordered list of numbers. And these charge values create fields along the information tracks that go through this point. In this case, these two information tracks. Now, if we look at other world lines, we'll call this one Jill and this one Bob. Then the property values, the charge values at this point on Alice create a field along this information track over here. And this means that at this point on Jill, we will have property values of Jill and field values that are correlated to the property values of Alice at this point. And the same for Bob. At this point over here, we will have property values of Bob and field values that are correlated to the property values of Alice at this point over here. Now the field is not created along the whole of the information tracks, only in one direction of them. And in our model, we will say the field values are created only in the upward part of the information tracks. So if we look at this point over here, on the information tracks that goes through this point, the field values at this point are not correlated to the property values of Alice at this point over here. Now if we look at another point on Alice, this point over here, it has property values of Alice, charges of Alice at this point, and these charges are the source of the field along these two information tracks. And as we said, only in the upward direction of these information tracks, it creates field value numbers that are correlated to the property values of this number. And again, when we look at Jill's world line at this point, then it will have the property values of Jill and field values that are correlated to the property values at this point of Alice. And the same for Bob. Bob property values at this point and field values that are correlated to this point on Alice world line. Now we also said that there is the opposite direction that the field affects a charge. And what we mean by that is if we look at this point on Jill over here, we said it has charge values of Jill, and it has field values that affect these charge values. The way they affect these charge values is by changing the trajectory of Jill's world line from this point onward. And if we look at this point on Jill, it has again some charge values of Jill at this point, and also field values that affect these charges. And they affect these charges by changing the trajectory from this point onward. Now, if we look at a different point, let's look at a point on Bob over here. This point on Bob over here, it has Bob's charge values at this point. So these create fields along these information tracks. And again, this means that if we look at this world line, we'll call it Jack. At this point, the field values of this point of Jack are correlated to the source, the property values of Bob over here. And the same goes for this green point on Alice. The field values in this point on Alice world line are correlated to the same source on Bob, the charges of Bob at this point. However, even though they are both created by the same source, but the charges on Bob at this point, the field values are not the same on Jack and on Alice. And this is because what we said earlier. The further you are from the source, the smaller the field is. So because this point on Jack is closer to the source along the information track, the field values of it are stronger than the field values of this point on Alice that are further away from the source along the information track. Okay, so we said many things. Let's try to summarize them. The property or charge values are held by the points of the elementary particle world line. Each point on the world line has values in its property part of its ordered list of numbers. The charge creates a field along the information tracks that go through the point holding the charge. In our presentation, the field is created in the up direction. The field values decrease at points further along the information track from the source. And the source, as we said, is the charge. And finally, the field affects an elementary particle by changing the trajectory of its world line. If we look at this depiction, then it represents a situation where we turn off the effects of fields on charges. So we magically turned off these effects, these forces, and then physicists deduced the world lines would be straight lines. And the idea behind that is that, as we said, the effect of the field on the chart is to change the trajectory of the world line. And if we take this effect away, the trajectory of the world line does not want to change and it stays straight. So what we can say is that the natural form of a world line from our outside perspective is a straight line. And in physics, these are called inertial frames. So the following is a two-dimensional model of reality without forces and without gravity. If we turn these things off, then we get something that looks similar to this, straight world lines, and I depicted some information tracks to remind us that information tracks exist throughout all of reality. And if we turn back on the effects of fields on properties, the forces, then the trajectories of the world lines are no longer straight. And we get a depiction that looks something like this. Okay, in the next video we will elaborate and explain how the field values change the trajectory of the world lines, and explain why and how the field values decrease as they are further away from the source, and in general finish describing reality.